Good morning, Geometry Honor students. So this one is Mr. Chen again. So today I would like to talk about Chapter 4, Transformation. So the objective for the lesson today is about recognizing the differences of reflection, translation, rotation, and dilation. So for the reflection, translation, rotation, they all consider the rigid motion for the transformation. So dilation is something that's a little bit different compared to the rest of those. Okay. So any kind that I'm talking about the rigid motion, that means we don't change the shape, the area, or the dimension of the figure. Okay. So we don't change the dimension. So we don't change the perimeter, we don't change the area. So it's going to guarantee that it's going to be the exact same figure, it's the exact same shape. But dilation is not either making the figure smaller or bigger. Okay, so we'll take a look at that. Transformation, reflection, translation, rotation, and dilation are the basic transformation techniques. Okay, so we'll get to that. So reflections, so started off with the reflections. So we do have, in general, we do have 4 different types of reflections. Well, actually has more. But for the basic one, we do have the reflection over the x-axis, reflection over the y-axis, reflection over the line y equals x. So the line of symmetry. So if you're talking about like finding the inverse trig functions or the inverse functions for any kind of algebraic linear, nonlinear function. And then the other one is y equals negative x. So as you can see that the mapping here, so you see the arrow, so that means the mapping. So x comma y maps to x comma negative y. So the only thing that has been changed here is the y value. If that's considered positive, we just want to negate it, so convert it to its opposite, negative. So for the reflection over the x-axis, so let's say we do have point A, x comma y, so it turns out to be a prime, x comma negative y. Reflection over the y-axis, so x comma y maps to negative x comma y over the y-axis. And then the other one is y equals x, so the mapping here, so we just switch the xy value. And then for that y equals negative x, so besides switching the xy value, also for that the new x coordinate, so we just want to convert that y to its negative. So now let's look at that some of the example here. So reflections, so reflected the figure with the given points across the line. So this one, for the first one, it's over the y-axis, across the y-axis. So we do have 2 comma 3, so that means for a prime, so it's going to be written as negative 2 comma 3. Okay, so 2 comma 3 and then negative 2 comma 3. B prime, so it's going to be negative 5 comma 2. And then for C prime, it's going to be 2 comma negative 5. Okay, so basically we just want to plot those points and then simply connect them. Okay, so 2 comma 3, point A, 5 comma 2, point B, and then point C, negative 2, negative 5, down here. So it's going to be a triangle. Okay, so once you connect those dots, so it's a figure of a triangle. And then for A prime, B prime, C prime, so A prime, negative 2 comma 3. Okay, let's use red here. Label the point, A prime, B prime, negative 5, positive 2. So negative 5. And then positive 2. And then C prime, 2 comma negative 5. Okay, so again, for those 3 dots, so basically just connect them. As you can see that the figure, it's reflected over the line of symmetry, y-axis. Okay, so again, label the point. So A prime, B prime, and then C prime. So here's another one. So reflection over that the line y equals negative x. So besides switching the xy value, also we need to negate that the new x coordinate to its negative. So negative 4 comma negative 2. Okay, so y prime switch the xy value, so negative 1 comma 2, but also the x value you want to convert to its opposite, so it's 1 comma 2. And then the other one, z prime, switch the xy value, negate the x value, so negative 1 comma negative 5. So negative 2 comma 4, so basically just plot those points. Right up here. 2 comma negative 1. Negative 5 comma 1. Again, connect those dots. Triangle again. And then x prime, negative 4, negative 2. Okay, down here. 1 comma 2. Okay, supposed to be red. Okay, so x prime, y prime, and then z prime, negative 1 comma 5. 1, 2, 3, 4, 5 up here. So basically just connect those dots. Okay, making sure that this one is all right. So negative 4, negative 2, that's what I got here. So 1 comma 2. Oh, the other one, it's actually, excuse me, for z prime, it's negative 1, negative 5. So negative 1, negative 5 down here. Negative 1, negative 2, negative 3, negative 4, negative 5. Again, connect those dots. Okay, so that's what we found. Okay, so now let's see what else that we have for the rest of this. So here's another type of transformation, so translation. So translation is always showing that from one position to another position. It shows like the sliding, okay? So this one, anytime they do the translation, it shows with a given vector, AB. So anytime they see that AB, so that means you need to add those values along with that x coordinate and the y coordinate. Okay, so let's say that from point A to A prime. So this one, basically we just want to add A. So it's kind of like a rise over the run, so x plus A. And then for the run here, so we want to add B, y plus B. So we'll get a new coordinate, which is x plus A, comma y plus B. So translate the figure with the given vector, so negative 1, negative 6. So basically you just show the work, so g prime, so 2 plus negative 1, comma, and then 2 plus negative 6. Combine them, or basically just subtract. So what we found here, so 2 plus negative 1, so it's 1. Comma, negative 4. And then for h, similar, so h prime, so negative 3 plus negative 1, and then negative 3 minus 6. So the one that we found out here is negative 4, negative 9. And then for I prime, so basically go through the same kind of routine, so 5 plus negative 1, comma, negative 2 plus negative 6. So what we found here is 4, comma, negative 8. Okay. No, we don't need that extra mark. Okay, so now let's see what else that we have for this. Another type of transformation is rotation. So rotation in the coordinate plane, so two basic rotations. So normally we go by counterclockwise about the origin. So you might be wondering, why do we go by counterclockwise? Because the quadrant number, first quadrant, second quadrant, the third, and the fourth. So this one is always going by counterclockwise. Okay, so xy maps to negative y comma x. So this one is just like a general formula or a general technique to come up with a new position. And then for 180-degree counterclockwise about the origin. So this one x comma y. So start with the initial position, and then it rotates all the way to negative x, negative y. So x comma y maps to negative x, negative y. Okay, so let's do some example. So this one is pretty straightforward. So just plug in that. So -2, -4, convert x, y value to its negative or its opposite. So -3, 5 for b prime, and then c prime. So that would be what? 2, -3. And then the rest of that I just need to plot the point. So 3 position, 3 vertices. So triangle again, and then a prime, b prime, c prime. So 2, 4. So basically this one, just plot those points. 3, -5. And then -2, 3. Okay, so once you get all those points, so basically just connect them. So it's a triangle again. And then for a prime, b prime, c prime. Okay, so plot them. So -2, -4. B prime, -3, +5. And then 2, -3. So once you get those dots, so once again, just connect them. And as you can see that this one, it's showing that it's a rotation. Okay, so again, label the point. Okay, A prime, B prime, C prime. So 90-degree. So the formula for that 90-degree, so xy maps to -y, x. So u prime, so -y, x. So before you, after you switch them, also you want to change that y to its negative. So this will be 1, 1. So it's -y, x. V prime, 2, +4. W prime, so 5, 3. And then the rest of that, just plot the point. So quite similar to the previous one. But it shows that it's a 90-degree counterclockwise about the origin rotation. So the last piece right here is the dilation. So dilation in the xy plane. So we do have two different type of dilation. So one is called the enlargement. So let's say that k is greater than 1. So that means the figure is going to be expanded. It's going to be bigger. So the way to do it, xy maps to kx, ky. And then if k is less than 1, so basically it's the same formula, but k is a fraction. Okay, so k is a fractions. So this one is going to be considered reduction. Okay, so I should put in k, it's less than 1, and also it's greater than 0. It's a fraction. Okay, so it's going to be shrinking, reduction. So draw the image with the given vertices under the dilation with the given scale factor. So A, here's the scale factor. So it looks like this one's going to be enlargement. So A prime, it's going to be 1 times 2, which is 2. 0 times 2, 0. B prime, so 1 times 2, 2. -2 times 2, -4. Then C prime, -1 times 2, -2. -2 times 2, -4. Okay, so plot the point. So 1, 0, A. 1 comma negative 2, so that's B. And then C, negative 1, negative 2, down here. So it looks like this figure is a right triangle. So once you connect them, and then get a piece right here, so A prime, so 2 comma 0. Okay, let's use different color for this one. B prime, 2 negative 4. And then C prime, negative 2, negative 4. And as you can see that the figure is a whole lot bigger. Well, it's actually twice as big as the original one. Again, the dots, simply connect them. Yeah, this one should be perpendicular too. Okay, so 2 right triangles. So one is twice as big as the other. Okay, so now let's see what else. So the other one, scale factor, it's negative 1/2. So again, do the same thing. So find out J prime, K prime, L prime. So multiply by negative 1/2 is still considered 0, 0. And then K prime, 6 times negative 1/2, then that'll be negative 3. 2 times negative 1/2, that's negative 1. Cross cancel. So L prime, so negative 4 times negative 1/2, negative positive 2. And then 4 times negative 1/2, which is negative 2. And you might be wondering the negative, what happened to the negative? Well, the negative also shows that it's what? It's a reflection. So it's like x-axis reflections, y-axis reflections. So basically this one, besides being like a scale factor, 1/2, the negative, it shows that it's like a both reflection with x-axis and y-axis. Or you can just generalize it as a rotation with that 180 degree counterclockwise about the origin. Okay. So again, the rest of this, just plot the point, and then you'll see that the figure is going to be twice as small as the previous one, as the original one. Okay, so that's it. So thank you for watching the video today. So any questions that you have, so please feel free to put into the comments on the YouTube channel. Okay, so and if you guys do like the video, please subscribe it. So I'll see you guys next time. Have a great one.